Hi, welcome to Expertisor Academy. This is Giri, lecturer in physics. In this video, we discuss about the thin lens. So now verify the thin lens step by step. A lens is formed by a transparent material bounded between two spherical surfaces. Between two spherical surfaces are one plane and another spherical surface. So lens is formed by transparent material bounded between two spherical surfaces or one plane and another spherical surface. In a thin lens, the distance between the surfaces is very small. The distance between the two surfaces is very small in the thin lens. If there are two spherical surfaces, if there are two spherical surfaces, then there will be two center of curvature C1 and C2. Then there will be two centers of curvatures C1 and C2, and correspondingly two radii of curvature R1 and R2, and correspondingly two radii of curvature R1 and R2. So the center of curvature, it's nothing but the center of the spherical surface. So radius of curvature, it's nothing but the distance between optic center of the lens to center of curvature. A plane surface has its center of curvature C at infinity. The center of curvature and its radius of curvature is for plane surface is infinite. The terminologies of spherical mirrors also hold good very much for thin lens except for focal length. The terminologies of spherical mirrors also hold good very much for thin lens except focal length. So let's verify the primary and secondary focal lengths. Primary and secondary focal lengths. As the thin lens is formed by two spherical surfaces, the lens may separate two different media. It is the media to left and right of the lens may be different. Hence, we have two focal lengths. Here, the lens, either it is convex or concave, having two different media. For lens, either it is convex or concave, It contains the two focal lengths. First one, primary focal length, secondary focal point. The primary focus F1 is defined as a point where an object should be placed to give parallel emergent rays to the principal axis. The primary focus F1 is defined as a point where an object should be placed to give parallel emergent rays to the principal axis. So look at this. This is the primary focal point. The light rays started from this point. After refraction, the refracted light rays traveling parallel to the principal axis. For a convergent lens, such an object is a real object, and for a divergent lens, it is a virtual object. For a divergent lens, it is a virtual object. The distance PF, the distance PF1 is the primary focal length F1. Next, secondary focal point. The secondary focus F2 is defined as a point where all the parallel rays traveling close to the principal axis converge to form an image on the principal axis. So here the light rays parallel to the principal axis. After refraction, they converge at one point. So that is second focal point. For convergent lens, such an image is a real image. For divergent lens, it is virtual image. The distance PF2 is the secondary focal length F2. Sign conventions for lengths on focal length. The sign conventions for thin lenses differ only in signs followed for focal length. See that one first. The sign of focal length is not decided on the direction of measurement of the focal length from the pole of the lens, as they have two focal lengths, one to the left and another to the right. Primary and secondary focal lengths on either side of the lens. So there is a focal length on left and right. Second, the focal length of the thin lens is taken as positive for converging lens, negative for diverging lens. The focal length is taken as positive for thin lens, that is particularly converging lens. For diverging lens, it's a negative. The other sign conventions for object distance, image distance, radius of curvature, object height, image height. So except for above mentioned is focal lengths. So remain the same for thin lenses as that of spherical lens. So this is the information about the thin lens. Thanks for watching this video. For more videos visit www.expertisoracademy.com. Thank you.